Assalamualaikum and hi everybody. Alright, today we'll going to look at acid-base indicator and titration curve. So in this topic, you will explore about acid-base indicator. You might need to know the function of indicator, types of indicator. So also at the same time, you will learn about the titration curve, how to sketch the titration curve. So I classified with two types of titration curve known as a S curve and Z curve. And you need to calculate the pH, the initial pH, and after addition of several volume of solution into the analyte. So by using this formula, pH is equal to negative log concentration hydrogen ion. So before we going to acid-base indicator, so I would like to recall you back about acid-base titration. So acid-base titration is a method of quantitative analysis for determining the concentration of acid or base by exactly neutralizing it with standard solution or basic or acid having a known concentration, right, which is normally it will place in your burette. So for information, one tiny of solution from burette, you will change the pH dramatically. So that's why bila you buat eksperimen, bila saya kata first experiment dan second experiment, you drop tu masuk lagi separuh saya kata, tapi drop habis satu titik, ditukar terus color jadi sangat gelap kan warna dia. Alright, proceed to acid-base indicator. They are also known as a pH indicator. So also a substance which change color with pH, they are usually weak acid or base, which when dissolved in water dissociate slightly and form ion. So here is the equation, equilibrium equation that show the indicator equilibrium equation for the indicator with the conjugate base. So the function of using indicator is to monitor the progress and also to signal the completion of the acid-base reaction. So to signal the analyst or the chemist that doing the titration. So without the indicator, maybe it's quite hard to find the color changes. So by using indicator, it will help you a lot. So how is indicator used? Weak acid are titrated in the presence of indicator which change under slightly alkaline condition. Meanwhile, for weak bases should be titrated in the presence of indicator which change under slightly acidic condition. Alright, so now we are trying to identify what types of indicator you need to use in your experiment. Alright, so actually we have a plethora of different indicator. As you can see from this table 1, there is a lot of indicator can be used. But as I highlighted here, there is a methyl orange, methyl red, bromothymol blue, phenol red, and phenolphthalein. This is a common that you use in your experiment. Right? So there is a transition range here. Transition range need to match the endpoint pH as closely as possible in order to minimize titration error. So you might to know when your solution in burette and in conical flask. So what is the transition range actually? In order to make sure you will choose the correct indicator. Right, as you can see here, methyl orange is transition range between 3.1 until 4.4. Methyl red is 4.8 until 6.0, and so on. So how to make a choice since you have a lot number of this indicator? So here I suggest you to memorize only a few types of indicator. So for strong acid and strong base, so the endpoint range is between 3.3 to 10 pH. So your suitable indicator is any type of indicator. Okay, maybe you can use phenolphthalein and so on. So based on this table, so as you can see, phenolphthalein is 8 to 9.6. So the range is between the endpoint range is okay in the range. So for weak acid and strong base, you can use phenolphthalein and thermal blue because the endpoint is between 7 to 11. Strong acid with base 3.3 to 7, methyl orange and methyl red. So we are looking out the point at which neutralization occur, and that is where we call as an endpoint. So this is a titration of strong acid and strong base. We can look to this. So normally when we add strong acid is placed in your conical flask, meanwhile your sodium hydroxide is placed in your burette. So before addition of sodium hydroxide, so pH of HCl acid is at pH 1. When the sodium hydroxide being added, so the pH increase slowly at first. So near the equivalence point, the curve rises almost vertically. So any indicator which has effective range between pH 3.5 to 11 may be used to detect the equivalence point. For example, phenolphthalein and methyl orange. So beyond the equivalence point, the pH increases slowly. Okay, for example, here the point that you need to write down the proper one is number 1. You need to find out the initial pH. So as I said, the pH of acid is 1, so you need to write down here 1, and then it goes up and rises vertically. So at this point, at pH number 3, we show the pH at equivalence point, maybe 7, because this one is between strong acid versus strong base. Alright, for Z curve, so analyte is strong base, titrant is strong acid. So like this, if you can see from this picture, alright, so this is starting point, slow down. So when you add solution from burette, so start point you can add laju kan saya mention, and then you can add slowly and then until you reach the end point. But if let's say terlepas, dia akan jadi warna yang lebih gelap lah. Okay, so this is the titration curve of strong base versus with a strong acid. Right, this one normally equivalence point is at pH 7. So this is types of acid-base titration curve, S curve and Z curve. Alright, so S, remember for S curve is in your conical flask is acid, in your burette is base. Vice versa to Z curve, which is in your conical flask will place is the base, and also in your burette is acid. So you need to write down properly, indicate your graph, the pH, and also the volume sodium hydroxide added in milliliter. Right? So this is a calculation involved to find the pH at every stage of titration. So as you can see from this question, after addition of 10 ml of 0.1 molar sodium hydroxide to 25 ml of 0.1 molar HCl, so HCl is placed in your conical flask. So you add 10 ml of sodium hydroxide, so now you have the total volume is 35 ml. So first you need to find out the mole of sodium hydroxide at 10 ml of volume, and then mole of HCl in 25 milliliter. Here for your information, HCl is 25, sodium hydroxide is 10. So the remaining solution is hydrochloric acid. So that's why amount of HCl left after partial neutralization. So you minus mole of HCl minus mole of sodium hydroxide. So you will get the molarity, and then you need to find out the pH. Then you sketch the titration curve. So here the initial pH you calculate of this 25 ml and 0.1 molar HCl, you will get pH 1. Then you draw the line. So you got after 10 milliliter of base being added, so you got 1.37. Okay, then after addition 25 ml with 25 ml of 0.1 molar HCl, so you will get the amount of hydrogen ion and hydroxide ion is equal. So the pH is 7. So after addition of 35 ml, so now 35 ml over 25 ml, so meaning that now sodium hydroxide is dominant. So you calculate the moles of sodium hydroxide. So you calculate also at the same time the moles of HCl. So you minus dominant minus yang bukan dominant. So you will get the moles here. The moles dengan volume baru 60 ml. So you got the molarity. So from the molarity you can calculate the pH. You will get the 12.22 A and B. So you draw the line. Tadi starting is 1. Naik tadi pada 10 ml 1.37. After 25 ml being added, so you got the pH 7. So then you add another 35 ml of sodium hydroxide. Okay, so you will get the pH is 12.22. So dapatlah graf yang cantik ni lah. So this is how you nak lukis the curve. Okay, this is a question you need to tell yourself. So at the same time, you need to sketch a label titration curve yang betul. Okay, this is common ditanya dalam soalan exam. Okay, this is question 2 is from final exam question. So as you can see, the diagram below show the pH curve produced when a solution X in conical flask is titrated with a solution Y in burette. Okay, so meaning that is solution Y an acid or a base? Jelaslah, nampak kat situ. Is solution Y an acid or a base? So as you can see here, Y is placed in burette. So meaning that, what have I said? Base titration will give the above pH curve. Give an example. Give an example of acid-base pair that will give similar pH curve. Name a suitable indicator for the above titration. So you can refer back semula table tadi tu yang saya mention. You kena hafal beberapa jenis sahaja, bukan 3 atau 4 sahaja. Okay, this is question number 3. So saya minta awak try buat dan kita akan discuss dalam tutorial nanti. Okay, so we proceed to weak acid versus strong base. So the titration between acetic acid and sodium hydroxide. So acetic acid is memang common weak base ataupun awak jangan suka. So equivalence point, the pH is not 7 lagi dah. So above 7. Alright, and then there is therefore necessary to use indicator. So indicator apa nak guna pakai? Phenolphthalein. Ni boleh guna pakai ataupun methyl orange is not suitable. Okay, so proceed to this structure, this curve. So we'll get here. So this is the pH, starting pH of acetic acid. It's between 3 point something to 4. So the equivalence point is above. See, you can see here is above 7, maybe 8 or 8.5 or to 9. All right. This is a diagram to show that for weak acid versus strong base. Okay, the last one is the titration between hydrochloric acid and ammonia. So for information, hydrochloric acid is strong acid, ammonia is a weak base. Okay, ammonia NH3. So you will get like this. So equivalence point is below 7. Okay, equivalence point and endpoint is quite similar. So it is the point that show for endpoint is to show the color changes. Meanwhile, the equivalence point is from stoichiometric equation. So you need to know about this. Okay, normally equivalence point lies at between 5.3, 5 point something, and maybe 6. So indicator that's suitable might be used is methyl orange. So phenolphthalein is not suitable because its color changes occur away from the equivalence point. So this is how you draw the graph, the curve. So maybe you need to know also other types of base or acid that yang tak guna pakai dalam soal dalam nota saya ni, kita guna pakai juga. Okay, you need to identify by your own. Okay, so that's all we will discuss later in our tutorial. Assalamualaikum and bye.